when it makes one complete circle, it will make that half cycle made by the proton. So that is actually the cycloid motion in geometry. Now, if you have initial velocity non-zero, then when it comes first to the y-axis, it still sees the magnetic field, and therefore it tries to rotate. But by doing that, the velocity decreases, and therefore velocity decreases because electric field in the opposite direction. Velocity slows down, and therefore it wants to make a round circle, but that circle becomes small and then goes out and then becomes again this kind of motion is produced. So this is the card which is called torchite, and for electrons goes in the opposite direction with a some smaller circle because the radius, Larmor radius for protons and electrons are different. For the protons it is large because of the mass, and for electrons it is less. Now it can also be obtained mathematically. If you write down mdv/dt e plus, then one start with trial and error. One assume that V is equal to V1 plus Vd is assumed to be Ce cross by B square. It is because of some intuition, 1 E cross B by B square, and put that in that equation back. If you put that in the equation back, you write V is equal to V1 plus Vd. So one term will be V1 cross B, the other term will be Vd cross B, and then Vd cross B will be simple. You can make simplify, and you will find out finally an equation mdv1 by dt is equal to q by c d1 cross b. I did not do the simplification. Little bit algebra, you can do it. It's very simple, and therefore we get back the gyro motion with v1 and plus drift because of the electric field. So we have gyro motion plus drift, and drift is given by vdc e cross b by b square, which you can see independent of charge and mass. So the electrons and protons drift in the same velocity. So that's very important. And in this case, therefore, there is no current because electrons and protons move in the same velocity, in the same direction, and therefore there is no current. Now, more out of this simple expression, we can write electric field in terms of force, and force is given, electric field is given, electric field is given by the force by Q. So Q is replaced by F. Then Vd, which is given by C E cross by B square, E can be replaced by F by Q, and then you can see C F cross B by QB square. Now it becomes dependent on the charge. So in this case, the electrons will move in the opposite direction to the protons, and therefore some current can be produced. Let's see if M is equal to mg, gravity, then Vd can be written as C by Q M Q by B square. and that you can see that it depends upon both mass and charge of the particles. Obviously, protons, dvd is large, or electrons will be small. And I'm sure whenever you see this expression, C by Q and G by G cross B by B square, you probably remember something that happened in the ionosphere. You probably remember the Rayleigh-Taylor instability, which is driven, and there the electrons and protons, motion of the electron and protons due to gravity gives rise to an electric field, and that electric field is responsible for the generation of the instability, which finally leads it to the spread F. Now another important parameter is called the magnetic moment, and magnetic moment actually is like defined by into area, current obtained by the particles going around the magnetic field, and the area it describes when it completes one cycle. So that is given by current is obtained if you know the number of turns per unit time. So it is associated with the time, and that will determine how many turns it takes place in unit time. So that would be given by Q by C, and 1 by T would be given by the turns, number of turns, and that is defined by the time, 2 pi by omega, and the area is pi r L square. RL is the thermal radius, pi r L square is the area of the circle, and that you can write down on that side, and you get mu is equal to W perpendicular by B. Very important parameter as far as the magnetosphere. So we know now what is the expression for the magnetic moment. Magnetic moment is determined by the perpendicular velocity, perpendicular not velocity, perpendicular energy divided by magnetic field at any point. So that is the magnetic moment. Now let us go to some other phenomena or some other motion of the particle which will describe the characteristics of magnetic moment. We can have a magnetic mirror or a bottle which this appearance, this structure of the magnetic field was very important, or even the confinement of plasma in the mirror machine towards the fusion. Initially I tried with this, with the mirror machine. Now here we have actually the magnetic field. When you have divergence of B gives several components, 9 components, and we are here in the mirror only 3 components, Vx by dx, Vy by dy, Vz by dz. These 3 components exist, others do not exist. So the main field actually is Vz. So if you use our Maxwell's equation, the divergence of B equal to 0, you can express that in cylindrical coordinates, which I have written on the right hand side, delta delta r a r, delta 1 by r, delta delta theta, a theta, delta delta z. And if you put that in, we get an expression on the left hand side, 1 by r ddr of rbr plus dbz dz, which is equal to 0. Now we make some simplification and then make the integration. When the integration, one thing you have noticed that I have taken delta b delta dz out of the integral, and on the right hand side your integral is 0 to RL rdr. So if you integrate, now this is the integration, which then is given by RL rbr is equal to RL square by 2, because R square by 2 limit is RL, so RL square by 2 bz delta z with a minus sign. So the BR comes as minus RL by 2 dBz dB dz. So that is the R component of the magnetic. We get the R component of the magnetic field in this case from the equation, Maxwell's equation, and this is expressed in terms of dB dz. Interesting. Now, if you know dB dz, you can find out BR. So we can write down the equation of motion, the parallel component, and dV parallel dt, q by c v cross b parallel, and then you get q by c v perpendicular br, and q by c v perpendicular br is replaced by what we have got earlier, RL by 2 dBz dz, and finally you get that is equal to minus mu dB dz. Now what I wanted to say that the mass into acceleration is the force, and whenever you have slowly varying function of the magnetic field dB dz, and the force is given by minus mu delta bz dz, could be in general true, and we can write down minus mu gradient of b should be the force. Now one thing we have taken delta b delta z out of the integral because of the fact that it does not change in the region of Larmor radius. In that Larmor radius, delta b delta z does not change, and therefore it can get out of the grid. So we go back again, and dV parallel dt is equal to this, and that some simplification, dV parallel dz dz dt, which v parallel dV parallel dz minus mu like that, and half mv parallel square with ddz, you get minus mu delta b delta z, mv parallel square, it is a make w parallel mu minus mu dB dz. Here the total energy is conserved, as I have mentioned at the very beginning. So long as slowly magnetic field, the total energy is conserved, and therefore the dw parallel dz is equal to minus d perpendicular dz, and therefore in the left hand side we change it. What I want to say is that d mu dz equal to 0. What I want to emphasize in all these calculations, which will be quite boring to you at the moment, but what I want to emphasize is that the mu is a constant. The magnetic moment is a constant, and it is adiabatic invariant. Adiabatic in a sense that the magnetic field does not change its motion radius. So that is therefore the magnet adiabatic invariant. Similarly, you can have the electric field with time dependent, then also you get an extra drift, and that extra drift is C square I m q by b square delta E delta t, dependent on mass and charge, and this contribute to displacement current in Maxwell's equations. You know, this can be do this calculation again by going to the equation delta V delta T is equal to QE plus 1 by C V cross B. There you write V is equal to V1 plus Vd because of the electric field, which can be written as C E cross by V square, plus Vp, which is given by C square by E delta T. Now if you do that, find out that you are getting then the equation dv1 dz is equal to q v cross b by v square, and therefore you will get the motion in three different ways. You get the gyration plus the motion associated with the drift because of the constant electric field and because of the electric field which is dependent on time. So that gives you, as you can see, the Vp here depends on the charge and the mass of particles. Therefore, it produces, or protons and electrons will be different, and that produces a current. And therefore, you can look at the current you have. J is equal to this. It's simply algebra. You go do that, and you get J is equal to nc square b square I delta t. Now, if you have extra J because of the polarization field, then there will be some contribution to the equations, and the Maxwell's equation you get that T, and Jp is the external electric field, Jp is the electric field that is produced by the polarization or electric time dependent electric field. You can simply write that equation here. We get 4 pi j 1 plus 4 pi rho delta E delta T. That you can replace by epsilon. Epsilon is that part, and therefore you get delta D delta T. It is introduced at the dielectric nature of the plasma. In the case of when a time varying electric field exists, the dielectric.